Today we discovered the properties of a rectangle using the coordinate plane. In this example here, it says plot points A, B, C, and D. Create segment AB, BC, CD, AD, and diagonals AC and DB. Call O the center of the rectangle. Look at the rectangle provided above and do the measurement. Complete the sentences. So we're looking for the slope of AB. So we write AB here. Make sure you label your work. Use point A, which is -2, 1, and point B, which is 4, 3. Slope formula. We calculate, we get 3 minus, I think I need a new pen, equals 3 minus 1 over 4 minus -2, which becomes +2, and we get 1/3. AB, the slope of AB equals 1/3. Let's do BC. We use B and C. Okay, slope equals 0 minus 3 over 5 minus 4, which gives us -3 over 1, which gives us -3. The slope of BC here is -3. Let's find the slope of CD. We have C here is 5, 0. D is -1, -2. Plug it into our formula. We get -2 minus 0 over -1 minus 5 equals -2 over -6 equals 1/3. The slope of CD is 1/3. Let's do the slope of AD. We're using A, which is -2, 1, and we're using D, which is -1, -2. Put it into our equation. We get slope equals -2 minus 1 over -1 minus -2, which becomes +2. We get -3 over 1 equals -3. The slope of AD equals -3. So the slope of AB is 1/3. The slope of DC is 1/3. The slope of AD is -3, and the slope of BC is -3. Are the opposite sides parallel? So is this side parallel to this side? Yes. And how do I know? Because they have the same slope. So yes. Oh, let's check the other side. This side is parallel to this side as well because they have the same slope. So we can say yes, opposite sides are parallel because they have the same slope. So let's measure AB. We're going to use the distance formula to measure AB, DC, AD, and BC. So let's use our distance formula over here. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to start with side AD. So I have A is up here. I'm going to use these coordinates. We have distance equals the square root of x2 is going to be 4 minus x1, which is -2 squared, plus y2 is 3 and y1 is 1. So here we have 4 plus 2 gives me 6. 6 squared is 36. 3 minus 1 is 2. Squared gives me 4. 36. Distance equals the square root of 40, which splits up into the square root of 4 times the square root of 10, and we have distance equals 2 square root of 10. So the distance of AD here is 2 square root of 10. Now, since I don't have too much room, I'm going to erase and put the other 3 down here. I have AB. So the coordinates I'll be using for that are now, instead of here, here. Oh wait, that was side AB that I just found. Oops, sorry. 2 square root of 10. Oh my goodness, I'm driving myself crazy. Okay, so now we're going to move on to BC. Okay, and these are the coordinates that we'll be using. So, BC here, distance equals the square root of x2 is going to be 5 minus x1, which is 4, squared, plus y2 is 0 minus y1 is 3 squared. I'm going to get 9 plus 5 minus 4 gives me 1 squared, square root of 10. So BC here is going to be distance equals the square root of 10. Okay. So BC, square root of 10. Great. Now let's try with DC. Now we'll be using these coordinates here. And we have distance equals the square root of x2 here is negative 1, x1 here is 5, y2 is negative 2, y1 is 0. We have 4 plus 36, distance equals square root of 40, square root of 4, square root of 10, 2 square root of 10. DC is 2 square root of 10. Where is that one over here? DC here. Distance equals 2 square root of 10. Let's put AB on the figure as well. Distance equals 2 square root of 10. Okay, and then now let's find the final side that we need, which is going to be side AD. Now we will be using these coordinates here. I get x2 is negative 1 minus x1 is negative 2, so that becomes positive, and y2 is negative 2 minus 1 squared gives me 3 squared plus, oh, sorry, negative 3 squared, but it ends up being the same thing anyway. Let's just put 9. Okay? Plus negative 1 plus 2 gives me positive 1 squared. It gives me 1 square root. Distance equals square root of 10. Square root of 10. Distance equals square root of 10. Okay. Now let's look. Are opposite sides congruent? Opposite sides are AD here, BC here, and they both equal square root of 10, so yes. Let's double check with the other set of sides. AB here is 2 square root of 10, DC here is 2 square root of 10. Are they congruent? Yes. So are opposite sides congruent? Yes. Why? Because they have the same distance. Okay. Are all sides congruent? No, because 2 square root of 10 does not equal the square root of 10. And we have two sides at 2 square root of 10 and two sides at square root of 10. So let's measure angle A. I will get out my protractor, measure angle A, and I get 90 degrees here. I measure angle B, I get 90 degrees. Measure angle C, I get 90 degrees. and measure angle. This should be a D here. I get 90 degrees. Opposite angles are congruent? Yes. Why? Because angle A is congruent to angle C, and angle D is congruent to angle B. Now, in order to save our figure from before, I put the second part of questions right here and erase the old first part of questions. So number 5 says, is at least one pair of opposite sides parallel? Yes, at least one pair of opposite sides is parallel. Oh, wait, it says it's at least one pair. Okay, so no, because we just have one pair. So that's 2 sets. So yes, they are parallel. We have AD parallel to CB, and we have DC parallel to AB. So measure AC, measure BD. AC here. A is -3, 1. C is 5, 0. We're going to measure the distance between them. I plug in my values. I have distance equals the square root of x2 is 5 minus x1 is -3, so it becomes plus. And then y2 is 0 minus 1 squared. We get plus 1. 5 plus 3 is 8. Squared is 64. Distance equals the square root of 65. Now let's do BD. I'm just going to erase this part here, okay? I'll put BD up here for reference. B here is 4, 3. And D is -1, -2. Okay, so let's use those values. We have distance equals the square root of x2 is -1 minus 4 squared plus y2 is -2 minus 3 squared. So here we get distance equals the square root of -1 minus 4 gives me -5 squared gives me 25 plus -2 minus 3 more gives me -5 squared gives me 25. Distance equals the square root of 50. Oh wait, these should be equal. I must have made a mistake here. Let's see. -2 minus 3. Oh, I see what happened here. So A was actually -2, 1. So this here will be the square root of 50. I'll show you why. Look. If we thought A was -3, 1. I just read the picture wrong. It's actually right here. So A is -2, 1, right? And then C is 5, 0. So if I do a quick distance formula, right, I get x2 is 5 minus x1 squared plus y2 is 0 minus 1 gives me -1 squared. I get 1 plus 5 plus 2 is 7, 49 square root, distance equals square root of 50. Okay, sorry for that. But it's good to see people make mistakes and then how they go back and fix them and know what's right, what's wrong, right? So now we definitely know that the diagonals of a rectangle are congruent. Yes, because they are the same length. Okay, so now we have to measure BO. BO here. Let's say, hold on, let me go get a ruler. Okay, so BO here is going to be 2.5 centimeters. DO is 2.5 centimeters. AO is 2.5 centimeters. And OC is 2.5 centimeters. Oh, I think we were supposed to measure it with the ruler above. Okay, let's measure it with a ruler. or 5 centimeters, or 5 centimeters, okay? Do the diagonals bisect each other? Yes, because it splits the diagonals into 4 equal parts. And then here we measure angle BOA, and we get 110 degrees. We measure angle BOC, and we get 30 degrees. Are the diagonals perpendicular? No, because neither of the angles are right angles. Measure BAO here, and measure OAD here. BAO is going to be 30 degrees, and OAD is going to be 60 degrees. Do the diagonals bisect the vertices? No, because the angles are not equal. So now all this information is summarized on this chart here. This is the chart that you need to keep with you and keep it organized. So if you didn't get it during class, you can copy it now. That's it.